Section 1 of Omega, The Last Days of the World. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information, or to volunteer, please visit LibriVox.org. Omega, The Last Days of the World, by Camille Flammarion. Part 1, Chapter 1. The magnificent marble bridge which unites the Rue de Rennes with the Rue de Louvre, and which, lined with the statues of celebrated scientists and philosophers, emphasizes the monumental avenue leading to the new portico of the Institute, was absolutely black with people. A heaving crowd surged, rather than walked, along the quays, flowing out from every street, and pressing forward toward the portico, long before invaded by a tumultuous throng. Never, in that barbarous age preceding the Constitution of the United States of Europe, when might was greater than right, when military despotism ruled the world and foolish humanity quivered in the relentless grasp of war, never before, in the stormy period of a great revolution, or in those feverish days which accompanied a declaration of war, had the approaches of the House of the People's Representatives, or the Place de la Concorde, presented such a spectacle. It was no longer the case of a band of fanatics rallied about a flag, marching to some conquest of the sword, and followed by a throng of the curious and the idle, eager to see what would happen, but of the entire population, anxious, agitated, terrified, composed of every class of society without distinction, hanging upon the decision of an oracle, waiting feverishly the result of the calculations which a celebrated astronomer was to announce that very Monday, at 3 o'clock, in the session of the Academy of Sciences. Amid the flux of politics and society, the Institute survived, maintaining still in Europe its supremacy in science, literature, and art. The center of civilization, however, had moved westward, and the focus of progress shone on the shores of Lake Michigan in North America. This new palace of the Institute, with its lofty domes and terraces, had been erected upon the ruins remaining after the great social revolution of the international anarchists who, in 1950, had blown up the greater portion of the metropolis as from the vent of a crater. On the Sunday evening before, one might have seen from the car of a balloon all Paris abroad aboard the boulevards and public squares, circulating slowly and as if in despair, without interest in anything. The gay aerial ships no longer cleaved the air, aeroplanes and aviators had all ceased to circulate. The aerial stations upon the summits of the towers and buildings were empty and deserted. The course of human life seemed arrested, and anxiety was depicted upon every face. Strangers addressed each other without hesitation, and but one question fell from pale and trembling lips: "Is it then true?" The most deadly pestilence would have carried far less terror to the heart than the astronomical prediction on every tongue. It would have made fewer victims, for already, from some unknown cause, the death rate was increasing. At every instant one felt the electric shock of a terrible fear. A few, less dismayed, wished to appear more confident, and sounded now and then a note of doubt, even of hope, as "it may prove a mistake," or "it will pass on one side," or again, "it will amount to nothing, we shall get off with a fright," and other like assurances. But expectation and uncertainty are often more terrible than the catastrophe itself. A brutal blow knocks us down once for all, prostrating us more or less completely. We come to our senses, we make the best of it, we recover and take up life again. But this was the unknown, the expectation of something inevitable but mysterious, terrible, coming from without the range of experience. One was to die, without doubt, but how? By the sudden shock of collision, crushed to death? By fire, the conflagration of a world? By suffocation, the poisoning of the atmosphere? What torture awaited humanity? Apprehension was perhaps more frightful than the reality itself. The mind cannot suffer beyond a certain limit. To suffer by inches, to ask every evening what the morning may bring, is to suffer 1,000 deaths. Terror, that terror which congeals the blood in the veins, which annihilates the courage, haunted the shuddering soul like an invisible spectre. For more than a month the business of the world had been suspended. A fortnight before, the Committee of Administrators, formerly the Chamber and Senate, had adjourned, every other question having sunk into insignificance. For a week the exchanges of Paris, London, New York and Peking had closed their doors. What was the use of occupying oneself with business affairs, with questions of internal or foreign policy, of revenue or of reform, if the end of the world was at hand? Politics indeed! Did one even remember to have ever taken any interest in them? The courts themselves had no cases. One does not murder when one expects the end of the world. Humanity no longer attached importance to anything. Its heart beat furiously, as if about to stop forever. Every face was emaciated, every countenance discomposed and haggard with sleeplessness. Feminine coquetry alone held out, but in a superficial, hesitating, furtive manner, without thought of the morrow. The situation was indeed serious, almost desperate, even in the eyes of the most stoical. Never in the whole course of history had the race of Adam found itself face to face with such a peril. The portents of the sky confronted it unceasingly with a question of life and death. But let us go back to the beginning. 3 months before the day of which we speak, the director of the observatory of Mount Gaurisankar had sent the following telephonic message to the principal observatories of the globe, and especially to that of Paris. Footnote: For about 300 years the observatory of Paris had ceased to be an observing station, and had been perpetuated only as the central administrative bureau of French astronomy. Astronomical observations were made under far more satisfactory conditions, upon mountain summits in a pure atmosphere, free from disturbing influences. Observers were in direct and constant communication by telephone with the central office, whose instruments were used only to verify certain discoveries, or to satisfy the curiosity of savants detained in Paris by their sedentary occupation. End of footnote. A telescopic comet discovered tonight, in 290 degrees 15 minutes right ascension, and 21 degrees 54 minutes south declination, slight diurnal motion, is of greenish hue. Not a month passed without the discovery of telescopic comets, and their announcement to the various observatories, especially since the installation of intrepid astronomers in Asia on the lofty peaks of Gaurisankar, Dapsang, and Kachinjinga, in South America on Aconcagua, Iyampon, and Chimborazo, as also in Africa on Kilimanjaro, and in Europe on Elburz and Mont Blanc. This announcement, therefore, had not excited more comment among astronomers than any other of a like nature which they were constantly receiving. A large number of observers had sought the comet in the position indicated, and had carefully followed its motion. Their observations had been published in the New Astronomische Nachrichten, and a German mathematician had calculated a provisional orbit and ephemeris. Scarcely had this orbit and ephemeris been published, when a Japanese scientist made a very remarkable suggestion. According to these calculations, the comet was approaching the sun from infinite space in a plane but slightly inclined to that of the ecliptic, an extremely rare occurrence, and, moreover, would traverse the orbit of Saturn. It would be exceedingly interesting, he remarked, to multiply observations and revise the calculation of the orbit, with a view to determining whether the comet will come in collision with the rings of Saturn, for this planet will be exactly at that point of its path intersected by the orbit of the comet on the day of the latter's arrival. A young laureate of the Institute, a candidate for the directorship for the observatory, acting at once on this suggestion, had installed herself at the telephone office in order to capture on the wing every message. In less than 10 days she had intercepted more than 100 dispatches, and, without losing an instant, had devoted 3 nights and days to a revision of the orbit as based on this entire series of observations. The result proved that the German computer had committed an error in determining the perihelion distance, and that the inference drawn by the Japanese astronomer was inexact in so far as the date of the comet's passage through the plane of the ecliptic was concerned, this date being 5 or 6 days earlier than that first announced. But the interest in the problem increased, for the minimum distance of the comet from the earth seemed now less than the Japanese calculator had thought possible. Setting aside for the moment the question of a collision, it was hoped that the enormous perturbation which would result from the attraction of the earth and moon would afford a new method of determining with exhaustive precision the mass of both these bodies, and perhaps even throw important light upon the density of the earth's interior. It was indeed established that the celestial visitor was moving in a plane nearly coincident with that of the ecliptic, and would pass near the system of Saturn, whose attraction would probably modify to a sensible degree the primitive parabolic orbit, bringing it nearer to the belated planet. But the comet, after traversing the orbits of Jupiter and of Mars, was then to enter exactly that described annually by the Earth about the Sun. The interest of astronomers was not on this account any the less keen, and the young computer insisted more forcibly than ever upon the importance of numerous and exact observations. It was at the observatory of Gaurisankar especially that the study of the comet's elements was prosecuted. On this highest elevation of the globe, at an altitude of 8,000 meters, among eternal snows which, by newly discovered processes of electrochemistry, were kept at a distance of several kilometers from the station, towering almost always many hundred meters above the highest clouds in a pure and rarefied atmosphere, the visual power of both the eye and the telescope was increased 100-fold. The craters of the moon, the satellites of Jupiter, and the phases of Venus could be readily distinguished by the naked eye. For 9 or 10 generations, several families of astronomers had lived upon this Asiatic summit, and had gradually become accustomed to its rare atmosphere. The first comers had succumbed, but science and industry had succeeded in modifying the rigors of the temperature by the storage of solar heat, and acclimatization slowly took place, as in former times at Quito and Bogota, where, in the 18th and 19th centuries, a contented population lived in plenty, and young women might be seen dancing all night long without fatigue, whereas on Mont Blanc in Europe, at the same elevation, a few steps only were attended with painful respiration. By degrees a small colony was installed upon the slopes of the Himalayas, and, through their researches and discoveries, the observatory had acquired the reputation of being the first in the world. Its principal instrument was the celebrated equatorial of 100 meters focal length, by whose aid the hieroglyphic signals, addressed in vain for several thousand years by the inhabitants of the planet Mars to the Earth, had finally been deciphered. While the astronomers of Europe were discussing the orbit of the new comet, and establishing the precision of the computations which foretold its convergence upon the Earth and the collision of the two bodies in space, a new phonographic message was sent out from the Himalayan observatory. The comet will soon become visible to the naked eye, still of greenish hue. Its course is earthward. The complete agreement between the astronomical data, whether from European, American, or Asiatic sources, could leave no further doubt of their exactness. The daily papers sowed broadcast this alarming news, embellished with sinister comments and numberless interviews in which the most astonishing statements were attributed to scientists. Their only concern was to outdo the ascertained facts, and to exaggerate their bearing by more or less fanciful additions. As for that matter, the journals of the world had long since become purely business enterprises. The sole preoccupation of each was to sell every day the greatest possible number of copies. They invented false news, travestied the truth, dishonored men and women, spread scandal, lied without shame, explained the devices of thieves and murderers, published the formulae of recently invented explosives, imperiled their own readers, and betrayed every class of society, for the sole purpose of exciting to the highest pitch the curiosity of the public, and of selling copies. Everything had become a pure matter of business. For science, art, literature, philosophy, study and research, the press cared nothing. An acrobat, a runner or a jockey, an airship or water velocipede attained more celebrity in a day than the most eminent scientist or the most ingenious inventor, for these two classes made no return to the stockholders. Everything was adroitly decked out with the rhetoric of patriotism, a sentiment which still exercised some empire over the minds of men. In short, from every point of view, the pecuniary interests of the publication dominated all considerations of public interest and general progress. Of all this the public had been for a long time the dupe, but at the time of which we are now speaking it had surrendered to the situation, so that there was no longer any newspaper, properly speaking, but only sheets of notices and advertisements of a commercial nature. Neither the first announcement of the press, that a comet was approaching with a high velocity and would collide with the earth at a date already determined, nor the second, that the wandering star might bring about a general catastrophe by rendering the atmosphere irrespirable, had produced the slightest impression. This twofold prophecy, if noticed at all by the heedless reader, had been received with profound incredulity, attracting no more attention than the simultaneous announcement of the discovery of the Fountain of Perpetual Youth in the cellars of the Palais des Fées on Montmartre, erected on the ruins of the Cathedral of the Sacré-Cœur. Moreover, astronomers themselves had not at first evinced any anxiety about the collision, so far as it affected the fate of humanity, and the astronomical journals, which alone retained any semblance of authority, had as yet referred to the subject simply as a computation to be verified. Scientists had treated the problem as one of pure mathematics, regarding it only as an interesting case of celestial mechanics. In the interviews to which they had been subjected, they had contented themselves with saying that a collision was possible, even probable, but of no interest to the public. Meanwhile a new message was received by telephone, this time from Mount Hamilton in California, which produced a sensation among the chemists and physiologists. Spectroscopic observation establishes the fact that the comet is a body of considerable density, composed of several gases, the chief of which is carbonic oxide. Matters were becoming serious. That a collision with the earth would occur was certain. If astronomers were not especially preoccupied by this fact, accustomed as they were for centuries to consider these celestial conjunctions as harmless, if the most celebrated even of their number had at last coldly shown the door to the many beardless reporters constantly importuning them, declaring that this prediction was of no interest to the people at large, and was a strictly astronomical question which did not concern them, physicians, on the other hand, had begun to agitate the subject, and to discuss gravely among each other the possibilities of asphyxia or poisoning. Less indifferent to public opinion, so far from turning a cold shoulder to the journalists, they had welcomed them, and in a few days the subject suddenly entered upon a new phase. From the domain of astronomy it had passed into that of philosophy, and the name of every well-known or famous physician appeared in large letters on the title pages of the daily papers. Their portraits were reproduced in the illustrated journals, and the formula, "Interviews on the Comet," was to be seen on every hand. Already, even, the variety and diversity of conflicting opinions had created hostile camps, which hurled at each other the most grotesque abuse, and asserted that all physicians were charlatans eager for notoriety. In the meantime, the director of the Paris Observatory, having at heart the interests of science, was profoundly disturbed by an uproar which had more than once, on former occasions, singularly misrepresented astronomical facts. He was a venerable old man who had grown gray in the study of the great problems of the constitution of the universe. His utterances were respected by all, and he had decided to make a statement to the press in which he declared that all conjectures made prior to the technical discussion authorized by the Institute were premature. It has been remarked, we believe, that the Paris Observatory, always in the van of every scientific movement, by virtue of the labors of its members, and more especially of improved methods of observation, had become on the one hand the sanctuary of theoretical research, and on the other the central telephone bureau for stations established at a distance from the great cities on elevations favored by a perfectly transparent atmosphere. It was an asylum of peace, where perfect concord reigned, where astronomers disinterestedly consecrated their whole lives to the advancement of science, and mutually encouraged each other, without experiencing any of the pangs of envy, each forgetting his own merit to proclaim that of his colleagues. The director set the example, and when he spoke, it was in the name of all. He published a technical discussion, and he was listened to, for a moment, for the question appeared to be no longer one of astronomy. No one denied or disputed the meeting of the comet with the earth. That was a fact which mathematics had rendered certain. The absorbing question now was the chemical constitution of the comet. If the earth, in its passage through it, was to lose the oxygen of its atmosphere, death by asphyxia was inevitable. If, on the other hand, the nitrogen was to combine with the cometary gases, death was still certain, but death preceded by an ungovernable exhilaration, a sort of universal intoxication, a wild delirium of the senses, being the necessary result of the extraction of nitrogen from the respirable air, and the proportionate increase of oxygen. The spectroscope indicated especially the presence of carbonic oxide in the chemical constitution of the comet. The chief point under discussion in the scientific reviews was whether the mixture of this noxious gas with the atmosphere would poison the entire population of the globe, human and animal, as the president of the Academy of Medicine affirmed would be the case. Carbonic oxide! Nothing else was talked of. The spectroscope could not be in error. Its methods were too sure, its processes too precise. Everybody knew that the smallest admixture of this gas with the air we breathe meant a speedy death. Now, a later dispatch from the observatory of Gaurisankar had more than confirmed that received from Mount Hamilton. This dispatch read: "The Earth will be completely submerged in the nucleus of the comet, whose diameter is already 30 times that of the globe and is daily increasing." 30 times the diameter of the Earth! Even then, though the comet should pass between the Earth and the Moon, it would touch them both, since a bridge of 30 Earths would span the distance between our world and the Moon. Then, too, during the 3 months whose history we have recapitulated, the comet had emerged from regions accessible only to the telescope, and had become visible to the naked eye. In full view of the Earth it hovered now like a threat from heaven among the army of stars. Terror itself, advancing slowly but inexorably, was suspended like a mighty sword above every head. A last effort was made, not indeed to turn the comet from its path, an idea conceived by that class of visionaries who recoil before nothing, and who had even imagined that an electric storm of vast magnitude might be produced by batteries suitably distributed over that face of the globe which was to receive the shock, but to examine once more the great problem under every aspect, and perhaps to reassure the public mind and rekindle hope by the discovery of some error in the conclusions which had been drawn, some forgotten fact in the observations or computations. This collision might not after all prove so fatal as the pessimists had foretold. A general presentation of the case from every point of view was announced for this very Monday at the Institute, just 4 days before the prophesied moment of collision, which would take place on Friday, July 13th. The most celebrated astronomer of France, at that time director of the Paris Observatory, the president of the Academy of Medicine, an eminent physiologist and chemist, the president of the Astronomical Society, a skillful mathematician, and other orators also, among them a woman distinguished for her discoveries in the physical sciences, were among the speakers announced. The last word had not yet been spoken. Let us enter the venerable dome and listen to the discussion. But before doing so, let us ourselves consider this famous comet, which, for the time being, absorbed every thought. End of Chapter 1.
Of Omega, the Last Days of the World. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Omega, the Last Days of the World, by Camille Flammarion. Part 1, Chapter 2. The stranger had emerged slowly from the depths of space. Instead of appearing suddenly, as more than once the great comets have been observed to do, either because coming into view immediately after their perihelion passage, or after a long series of storms or moonlight nights has prevented the search of the sky by the comet seekers, this floating star mist had at first remained in regions visible only to the telescope, and had been watched only by astronomers. For several days after its discovery, none but the most powerful equatorial of the observatories could detect its presence, but the well-informed were not slow to examine it for themselves. Every modern house was crowded with a terrace, partly for the purpose of facilitating aerial embarkations. Many of them were provided with revolving domes. Few well-to-do families were without a telescope, and no home was complete without a library well furnished with scientific books. The comet had been observed by everybody, so to speak, from the instant it became visible to instruments of moderate power. As for the laboring classes, whose leisure moments were always provided for, the telescopes set up in the public squares had been surrounded by impatient crowds from the first moment of visibility, and every evening the receipts of these astronomers of the open air had been incredible and without precedent. Many workmen, too, had their own instruments, especially in the provinces, and justice as well as truth compels us to acknowledge that the first discoverer of the comet, outside of the professional observers, had not been by a man of the world, a person of importance, or an academician, but a plain workman of the town of Soissons, who passed the greater portion of his nights under the stars, and who had succeeded in purchasing out of his laboriously accumulated savings an excellent little telescope with which he was in the habit of studying the wonders of the sky. And it is a notable fact that prior to the 24th century nearly all the inhabitants of the earth had lived without knowing where they were, without even feeling the curiosity to ask, like blind men with no other preoccupation other than the satisfaction of their appetites. But within 100 years the human race had begun to observe and reason upon the universe about them. To understand the path of the comet through space, it will be sufficient to examine carefully the accompanying chart. It represents the comet coming from infinite space obliquely towards the earth, and afterwards falling into the sun, which does not arrest it in its passage toward perihelion. No account had been taken of the perturbation caused by the earth's attraction, whose effect would be to bring the comet nearer to the earth's orbit. All the comets which gravitate about the sun, and they are numerous, describe similar elongated orbits, ellipses, one of whose foci is occupied by the solar star. The drawing on page 33 gives an idea of the intersections of the cometary and planetary orbits, and the orbit of the earth about the sun. On studying these intersections, we perceive that a collision is neither an impossible nor an abnormal event. The comet was now visible to the naked eye. On the night of the new moon, the atmosphere being perfectly clear, it had been detected by a few keen eyes without the aid of a glass, not far from the zenith, near the edge of the Milky Way to the south of the star Omicron on the constellation of Andromeda, as a pale nebula, like a puff of very light smoke, quite small, almost round, slightly elongated in a direction opposed to that of the sun, a gaseous elongation outlining a rudimentary tail. This indeed had been its appearance since its first discovery by the telescope. From its inoffensive aspect, no one could have suspected the tragic role which this new star was to play in the history of humanity. Analysis alone indicated its march toward the earth. But the mysterious star approached rapidly. The very next day the half of those who searched for it had detected it, and the following day only the near-sighted, with eyeglasses of insufficient power, had failed to make it out. In less than a week everyone had seen it. In all the public squares, in every city, in every village, groups were to be seen watching it or showing it to others. Day by day it increased in size. The telescope began to distinguish distinctly a luminous nucleus. The excitement increased at the same time, invading every mind. When after the first quarter, and during the full moon, it appeared to remain stationary and even to lose something of its brilliancy, as it had been expected to grow rapidly larger, it was hoped that some error had crept into the computations, and a period of tranquillity and relief followed. After the full moon the barometer fell rapidly. A violent storm center, coming from the Atlantic, passed north of the British Isles. For 12 days the sky was entirely obscured over nearly the whole of Europe. Once more the sun shone in purified atmosphere. The clouds dissolved, and the blue sky reappeared pure and unobscured. It was not without emotion that men waited for the setting of the sun, especially as several aerial expeditions had succeeded in rising above the cloud belts, and aeronauts had asserted that the comet was visibly larger. Telephone messages sent out from the mountains of Asia and America announced also its rapid approach. But great was the surprise when at nightfall every eye was turned heavenward to seek the flaming star. It was no longer a comet, a classical comet such as one had seen before, but an aurora borealis of a new kind, a gigantic celestial fan with 7 branches shooting into space, 7 greenish streamers which appeared to issue from a point hidden below the horizon. no one had the slightest doubt but that this fantastical aurora borealis was the comet itself, a view confirmed by the fact that the former comet could not be found anywhere among the starry host. The apparition differed, it is true, from all popularly known cometary forms, and the radiating beams of the mysterious visitor were of all forms the least expected. But these gaseous bodies are so remarkable, so capricious, so various, that everything is possible. Moreover, it was not the first time that a comet had presented such an aspect. Astronomy contained among its records that of an immense comet observed in 1744, which at that time had been the subject of much discussion, and whose picturesque delineation, made de visu by the astronomer Chezeaux at Lausanne, had given it a wide celebrity. But even if nothing of this nature had been seen before, the evidence of one's eyes was indubitable. Meanwhile discussions multiplied, and a veritable astronomical tournament was commenced in the scientific reviews of the entire world. The only journals which inspired any confidence amid the epidemic of buying and selling which had for so long a time possessed humanity. The main question, now that there was no longer any doubt that the star was moving straight toward the earth, was its position from day to day, a question depending upon its velocity. The young computer of the Paris Observatory, chief of the section of comets, sent every day a note to the official journal of the United States of Europe. A very simple mathematical relation exists between the velocity of every comet and its distance from the sun. Knowing the former, one can at once find the latter. In fact, the velocity of the comet is simply the velocity of a planet multiplied by the square root of 2. Now, the velocity of a planet, whatever its distance, is determined by Kepler's third law, according to which the squares of the times of revolution are to each other as the cubes of the distances. Nothing evidently can be more simple. Thus, for example, the magnificent planet Jupiter moves about the sun with a velocity of 13,000 meters per second. A comet at this distance moves, therefore, with the above mentioned velocity multiplied by the square root of 2, that is to say, by the number 1.4142. This velocity is consequently 18,380 meters per second. The planet Mars revolves around the sun at the rate of 24,000 meters per second. At this distance the comet's velocity is 34,000 meters per second. The mean velocity of the earth in its orbit is 29,460 meters per second, a little less in June, a little more in December. In the neighborhood of the earth, therefore, the velocity of the comet is 41,660 meters, independently of the acceleration which the earth might occasion. These facts the laureate of the Institute called to the attention of the public, which, moreover, already possessed some general notions upon the theory of celestial mechanics. When the threatening star arrived at a distance from the sun equal to that of Mars, the popular fear was no longer a vague apprehension. It took definite form, based as it was upon the exact knowledge of the comet's rate of approach. 34,000 meters per second meant 2,040 kilometers per minute, or 122,400 kilometers per hour. At the distance of the orbit of Mars from that of the earth is only 76 million of kilometers, at the rate of 122,400 kilometers an hour. This distance would be covered in 621 hours, or about 26 days. But as the comet approached the sun, its velocity would increase, since at the distance of the earth its velocity would be 41,660 meters per second. In virtue of this increase of speed, the distance between the two orbits would be traversed by a comet in 558 hours, or in 23 days, 6 hours. But the earth, at the moment of meeting with the comet, would not be exactly at that point of its orbit intersected by a line from the comet to the sun, because the former was not advancing directly toward the latter. The collision, therefore, would not take place for nearly a week later, namely, at about midnight on Friday the 13th of July. It is unnecessary to add that under such circumstances the usual arrangements for the celebration of the national fete of July 14th had been forgotten. National fete? No one thought of it. Was not that date far more likely to mark the universal doom of men and things? As to that, the celebration by the French of the anniversary of that famous day had lasted, with some exceptions it is true, for more than 5 centuries. Even among the Roman anniversaries had never been observed for so long a period, and it was generally agreed that the 14th of July had outlived its usefulness. It was now Monday, the 8th of July. For 5 days the sky had been perfectly clear, and every night the fan-like comet hovered in the sky depths, its head or nucleus distinctly visible and dotted with luminous points which might well be solid bodies several kilometers in diameter, and which, according to the calculations, would be the first to strike the earth, the tail being in a direction away from the sun, and in the present instance behind and obliquely situated with reference to the direction of motion. The new star blazed in the constellation of Pisces. According to observations taken on the preceding evening, July 8th, its exact position was right ascension 23 hours 10 minutes 32 seconds, declination north 7 degrees 36 minutes 4 seconds. The tail lay entirely across the constellation of Pegasus. The comet rose at 9 hours 49 minutes and was visible all night long. During the lull of which we have spoken, a change in public opinion had occurred. From a series of retrospective calculations, an astronomer had proved that the earth had already on several occasions encountered comets, and that each time the only result had been a harmless shower of shooting stars. But one of his colleagues had replied that the present comet could not in any sense be compared to a swarm of meteors, that it was gaseous, with a nucleus composed of solid bodies, and he had in this connection recalled the observations made upon a comet famous in history, that of 1811. This comet of 1811 justified in a certain respect a real apprehension. Its dimensions were recalled to mind, its length of 180 million kilometers, and that is to say, a distance greater than that of the earth from the sun, and the width of its tail at its extreme point 24 million kilometers. The diameter of its nucleus measured 1,800,000 kilometers, 40,000 times that of the earth, and its nebulous and remarkably regular elliptical head was a spot brilliant as a star, having itself a diameter of no less than 200,000 kilometers. The spot appeared to be of great density. It was observed for 16 months and 22 days. But the most remarkable feature of this comet was the immense development to which it attained without approaching very close to the sun, for it did not reach a point nearer than 150 million kilometers, and thus remained more than 170 million kilometers from the earth. As the size of comets increases as they near the sun, if this one had experienced to a greater degree the solar action, its appearance would certainly have been still more wonderful and doubtless terrifying to the observer. And as its mass was far from insignificant, if it had fallen directly into the sun, its velocity, accelerated to the rate of 500,000 or 600,000 meters per second at the moment of collision, might, by the transformation of mechanical energy into thermal energy, have suddenly increased the solar radiation to such a degree as to have utterly destroyed in a few days every trace of vegetable and animal life upon the earth. A physicist, indeed, had made this curious remark, that a comet of the same size as that of 1811, or greater, might thus bring about the end of the world without actual contact, by a sort of expulsion of solar light and heat, analogous to that observed in the case of temporary stars. The impact would indeed give rise to a quantity of heat 6 times as great as that which would be produced by the combustion of a mass of coal equal to the mass of the comet. It had been shown that if such a comet, in its flight, instead of falling into the sun, should collide with our planet, the end of the world would be by fire. If it collided with Jupiter, it would raise the temperature of that globe to such a point as to restore it to its lost light, and to make it for a time a sun again, so that the earth would be lighted by two suns, Jupiter becoming a sort of minor night sun, far brighter than the moon, and shining by its own light of a ruby red or garnet color, revolving about the earth in 12 years, a nocturnal sun, and that is to say, no more real night for the earth. The most classical astronomical treatises had been consulted. Chapters on comets written by Newton, Halley, Maupertuis, Lalande, Laplace, Arago, Faye, Newcomb, Holden, Denning, Robert Ball, and their successors had been reread. The opinion of Laplace had made the deepest impression, and his language had been textually cited. The earth's axis and rotary motion changed, the oceans abandoning their old-time beds to rush toward the new equator, the majority of men and animals overwhelmed by this universal deluge, or destroyed by the violent shock, entire species annihilated, every monument of human industry overthrown. Such are the disasters which might result from collision with a comet. Thus discussion, researches into the past, calculations, conjectures succeeded each other, but that which made the deepest impression on every mind was first that, as proved by observation, the present comet had a nucleus of considerable density, and second, that carbonic oxide gas was unquestionably the chief chemical constituent. Fear and terror resumed their sway. Nothing else was thought about or talked about but the comet. Already inventive minds sought some way, more or less practicable, of evading the danger. Chemists pretended to be able to preserve a part of the oxygen of the atmosphere. Methods were devised for the isolation of this gas from the nitrogen, and its storage in immense vessels of glass hermetically sealed. A clever pharmacist asserted that he had condensed it in pastilles, and in a fortnight expended 8 millions in advertising. Thus commerce made capital out of everything, even universal death. All hope was not, however, abandoned. People disputed, trembled, grew anxious, shuddered, died even, but hoped on. The latest news was to the effect that the comet, developing as it approached the thermal and electric influences of the sun, would have at the moment of impact a diameter 65 times that of the earth, or 828,000 kilometers. It was in the midst of this state of general anxiety that the session of the Institute, whose utterance was awaited as the last word of an oracle, was opened. The director of the Observatory of Paris was naturally to be the first speaker, but what seemed to excite the greatest interest in the public was the opinion of the president of the Academy of Medicine on the probable effects of carbonic oxide. The president of the Geological Society of France was also to make an address, and the general object of the session was to pass in review all the possible ways in which our earth might come to an end. Evidently, however, the discussion of its collision with the comet would hold the first place. As we have just seen, the threatening star hung above every head. Everybody could see it. It was growing larger day by day. It was approaching with an increasing velocity. It was known to be at a distance of only 17,992,000 kilometers, and that this distance would be passed over in 5 days. Every hour brought this menacing hand ready to strike. 149,000 kilometers nearer. In 6 days, anxious humanity would breathe freely or not at all. End of chapter 2. Three of Omega, the last days of the world. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Omega, the last days of the world, by Camille Flammarion, Part 1, Chapter 3. Never within the history of man Had the immense hemicycle, constructed at the end of the 20th century, been invaded by so compact a crowd, it would have been mechanically impossible for another person to force an entrance. The amphitheater, the boxes, the tribunes, the galleries, the aisles, the stairs, the corridors, the doorways, all to the very steps of the platform, were filled with people sitting or standing. Among the audience were the President of the United States of Europe, the Director of the French Republic, the Directors of the Italian and Iberian Republics, the Chief Ambassador of India, the Ambassadors of the British, German, Hungarian, and Muscovite Republics, the King of the Congo, the President of the Committee of Administrators, all the ministers, the Prefect of the International Exchange, the Cardinal Archbishop of Paris, the Director General of Telephones, the President of the Council of Aerial Navigation and Electric Roads, the Director of the International Bureau of Time, the principal astronomers, chemists, physiologists, and physicians of France, a large number of state officials, formerly called deputies or senators, many celebrated writers and artists, in a word, a rarely assembled galaxy of the representatives of science, politics, commerce, industry, literature, and every sphere of human activity. The platform was occupied by the president, vice presidents, permanent secretaries, and orators of the day. But they did not wear, as formerly, the green coat and chapeau or the old-fashioned sword. They were dressed simply in civil costume, and for 2 centuries and a half every European decoration had been suppressed. Those of Central Africa, on the contrary, were of the most brilliant description. Domesticated monkeys, which for more than half a century had filled every place of service, impossible otherwise to provide for, stood at the doors, in conformity to the regulations, rather than to verify the cards of admission. For long before the hour fixed upon every place had been occupied, the President opened the session as follows. Now it is needless to remind the reader that the language of the 35th century is here translated into that of the 19th. Ladies and gentlemen, you all know the object for which we are assembled. Never certainly has humanity passed through such a crisis as this. Never indeed has this historic room of the 20th century contained such an audience. The great problem of the end of the world has been for a fortnight the single object of discussion and study among savants. The results of their discussions and researches are now to be announced. Without further preamble, I give place to the director of the observatory. The astronomer immediately arose, holding a few notes in his hand. He had an easy address, an agreeable voice, and a pleasant countenance. His gestures were few and his expression pleasing. He had a broad forehead, and a magnificent head of curling white hair framed his face. He was a man of learning and of culture, as well as of science, and his whole personality inspired both sympathy and respect. His temperament was evidently optimistic, even under circumstances of great peril. Scarcely had he begun to speak when the mournful and anxious faces before him became suddenly calm and reassured. "Ladies," he began, "I address myself first to you, begging you not to tremble in this way before a danger which may well be less terrible than it seems. I hope presently to convince you, by the arguments which I shall have the honor to lay before you, that the comet, whose approach is expected by the entire race, will not involve the total ruin of the earth. Doubtless we may and should expect some catastrophe, but as for the end of the world, really, everything would lead us to believe that it will not take place in this manner. Worlds die of old age, not by accident, and ladies, you know better than I that the world is far from being old. Gentlemen, I see before me representatives of every social sphere, from the highest to the most humble. Before a danger so apparent, threatening the destruction of all life, it is not surprising that every business operation should be absolutely suspended. Nevertheless, as for myself, I confess that if the Bourse was not closed, and if I had never had the misfortune to be interested in speculation, I should not hesitate today to purchase securities which have fallen so low." This sentence was finished Before a noted American Israelite, a prince of finance, director of the journal of the 25th Century, occupying a seat on one of the upper steps of the amphitheater, forced his way, one hardly knows how, through the rows of benches, and rolled like a ball to the corridor leading to an exit, through which he disappeared. After the momentary interruption caused by this unexpected sequel to a purely scientific remark, the orator resumed. "Our subject," he said, "may be considered under three heads. 1. Is the collision of the comet with the earth certain? If this question is answered in the affirmative, we shall have to examine 2. The nature of the comet, and 3. The possible effects of a collision. I have no need to remind so intelligent an audience as this that the prophetic words 'end of the world,' so often heard today, signify solely 'end of the earth,' which moment indeed of all others has the most interest for us. If we are able to answer the first question in the negative, it will be quite superfluous to consider the other two, which would become of secondary interest. Unfortunately, I must admit that the calculations of the astronomers are in this case, as usual, entirely correct. Yes, the comet will strike the earth, and doubtless with maximum force, since the impact will be direct. The velocity of the earth is 29,400 meters per second. That of the comet is 41,660 meters, plus the acceleration due to the attraction of our planet. The initial velocity of contact, therefore, will be 72,000 meters per second. The collision is inevitable, with all its consequences, if the impact of the comet is direct, but it will be slightly oblique. But do not for this reason take matters so to heart. In itself the collision proves nothing. If it were announced, for example, that a railway train was to encounter a swarm of flies, this prediction would not greatly trouble the traveler. It may well be that the collision of our earth with this nebulous star will be of the same nature. Permit me now to examine calmly the two remaining questions. First, what is the nature of the comet? That everyone knows already. It is a gas whose principal constituent is carbonic oxide. Invisible under ordinary conditions, at the temperature of stellar space, 273 degrees below zero, this gas is in a state of vapor, even of solid particles. The comet is saturated with them. I shall not in this matter dispute in the least the discoveries of science. This confession deepened anew the painful expression on the faces of most of the audience, and here a long sigh was drawn. "But, gentlemen," resumed the astronomer, "until one of our eminent colleagues of the section of physiology or of the Academy of Medicine deigns to prove for us that the density of the comet is sufficient to admit of its penetration into our atmosphere, I do not believe that its presence is likely to exert a fatal influence upon human life. I say is likely, for it is not possible to affirm this with certainty, although the probability is very great. One might perhaps wager 1,000,000 to 1. In any case, only those affected with weak lungs will be its victims. It will be a simple influenza, which may increase 3 or 5-fold the daily death rate. If, however, as the telescopes and camera agree in indicating, the nucleus contains large mineral masses, probably of a metallic nature, uranolites measuring several kilometers in diameter and weighing some millions of tons, one cannot but admit that the localities where these masses will fall with the velocity referred to a moment ago would be utterly destroyed. Let us observe, however, that 3/4 of the globe is covered with water. Here again is a contingency, not so important doubtless as the first, but nevertheless in our favor. These masses may perhaps fall into the sea, forming possibly new islands of foreign origin, bringing in any case elements new to science, and it may be germs of unknown life. Geodesy would in this case be interested, and the form and rotary movement of the earth might be modified. Let us note also that not a few deserts mark the earth's surface. Danger exists assuredly, but it is not overwhelming. Besides these masses and these gases, perhaps also the bolides of which we were speaking, coming in clouds, will kindle conflagrations at various places on the continents. Dynamite, nitroglycerin, panclastic, and royalite would be playthings in comparison with what may overtake us. But this does not imply a universal cataclysm. A few cities in ashes cannot arrest the history of humanity. You see, gentlemen, from this methodical examination of the 3 points before us, it follows that the danger, while it exists, and is even imminent, is not so great, so overwhelming, so certain as is asserted. I will even say more. This curious astronomical event, which sets so many hearts beating and fills with anxiety so many minds, in the eyes of the philosopher scarcely changes the usual aspect of things. Each one of us must some day die, and this certainly does not prevent us from living tranquilly. Why should the apprehension of a somewhat more speedy death disturb the serenity of so many of us? Is the thought of our dying together so disagreeable? This should prove rather a consolation to our egotism. No, it is the thought that a stupendous catastrophe is to shorten our lives by a few days or years. Life is short, and each clings to the smallest fraction of it. It would even seem, from what one hears, that each would prefer to see the whole world perish, provided he himself survived, rather than die alone and know the world was saved. This is pure egoism. But, gentlemen, I am firm in the belief that this will be only a partial disaster, of the highest scientific importance, but leaving behind it historians to tell its story. There will be a collision, shock, and local ruin. It will be the history of an earthquake, of a volcanic eruption, of a cyclone. And thus spoke the illustrious astronomer. The audience appeared satisfied, calmed, tranquilized, in part at least. It was no longer the question of the absolute end of all things, but of a catastrophe from which, after all, one would probably escape. Whispered murmurs of conversation were to be heard. People confided to each other their impressions. Merchants and politicians even seemed to have perfectly understood the arguments advanced, when, at the invitation of the presiding officer, the president of the Academy of Medicine was seen advancing slowly toward the tribune. He was a tall man, spare, slender, erect, with a sallow face and ascetic appearance and melancholy countenance, bald-headed and wearing closely trimmed gray side whiskers. His voice had something cadaverous about it, and his whole personality called to mind the undertaker rather than the physician fired with the hope of curing his patients. His estimate of affairs was very different from that of the astronomer, and was apparent from the very first word he uttered. "Gentlemen," said he, "I shall be as brief as the eminent savant to whom we have just listened, although I have passed many a night in analyzing to the minutest detail the properties of carbonic oxide. It is about this gas that I shall speak to you, since science has demonstrated that it is the chief constituent of the comet, and that a collision with the earth is inevitable. These properties are terrible. Why not confess it? For the most infinitesimal quantity of this gas in the air we breathe is sufficient to arrest in 3 minutes the normal action of the lungs and to destroy life. Everybody knows that carbonic oxide, known in chemistry as CO, is a permanent gas without color, odor, or taste, and nearly insoluble in water. Its density in comparison with the air is 0.96. It burns in the air with a blue flame of slight illuminating power, like a funereal fire, the product of this combustion being carbonic anhydride. Its most notable property is its tendency to absorb oxygen. The orator dwelt upon these 2 words with great emphasis. In the great iron furnaces, for example, carbon, in the presence of an insufficient quantity of air, becomes transformed into carbonic oxide, and it is subsequently this oxide which reduces the iron to a metallic state by depriving it of the oxygen with which it was combined. In the sunlight carbonic oxide combines with chlorine and gives rise to oxychlorine, COCl2, a gas with a disagreeable, suffocating odor. The fact which deserves our more serious attention is that this gas is of the most poisonous character, far more so than carbonic anhydride. Its effect upon the hemoglobin is to diminish the respiratory capacity of the blood, and even in very small doses, by its cumulative effect, hinders to a degree altogether out of proportion to the apparent cause the oxygenizing properties of the blood. For example, blood which absorbs from 23 to 24 cubic centimeters of oxygen per 100 volumes absorbs only 1/2 as much in an atmosphere which contains less than 1,000th part of carbonic oxide. The 1/10,000th part even has a deleterious effect, sensibly diminishing the respiratory action of the blood. The result is not simple asphyxia, but an almost instantaneous blood poisoning. Carbonic oxide acts directly upon the blood corpuscles, combining with them and rendering them unfit to sustain life. Hematosis, that is the conversion of venous into arterial blood, is arrested. 3 minutes are sufficient to produce death. The circulation of the blood ceases. The black venous blood fills the artery as well as the veins. The latter, especially those of the brain, become surcharged, the substance of the brain becomes punctured, the base of the tongue, the larynx, the windpipe, the bronchial tubes become red with blood, and soon the entire body presents the characteristic purple appearance which results from the suspension of hematosis. But, gentlemen, the injurious properties of carbonic oxide are not the only ones to be feared. The mere tendency of this gas to absorb oxygen would bring about fatal results. To suppress, nay, even only to diminish oxygen, would suffice for the extinction of the human species. Everyone here present is familiar with that incident which, with so many others, marks the epoch of barbarism, when men assassinated each other legally in the name of glory and of patriotism. It is a simple episode of one of the English wars in India. Permit me to recall it to your memory. 146 prisoners had been confined in a room whose only outlets were 2 small windows opening upon a corridor. The first effect experienced by these unfortunate captives was a free and persistent perspiration, followed by insupportable thirst, and soon by great difficulty in breathing. They sought in various ways to get more room and air. They divested themselves of their clothes, they beat the air with their hats, and finally resorted to kneeling and rising together at intervals of a few seconds. But each time some of those whose strength failed them fell and were trampled under the feet of their comrades. Before midnight, that is, during the 4th hour of their confinement, all who were still living, and who had not succeeded in obtaining pure air at the windows, had fallen into a lethargic stupor or a frightful delirium. When a few hours later the prison door was opened, only 23 men came out alive. They were in the most pitiful state imaginable, every face wearing the impress of the death from which they had barely escaped. I might add 1,000 other examples, but it would be useless, for doubt upon this point is impossible. I therefore affirm, gentlemen, that on the one hand the absorption by the carbonic oxide of a portion of the atmospheric oxygen, or on the other the powerfully toxic properties of this gas upon the vital elements of the blood, alike seem to me to give to the meeting of our globe with the immense mass of the comet, in the heart of which we shall be plunged for several hours, I affirm, I repeat, that this meeting involves consequences absolutely fatal. For my part, I see no chance of escape. I have not spoken of the transformation of mechanical motion into heat, or of the mechanical and chemical consequences of the collision. I leave this aspect of the question to the permanent secretary of the Academy of Sciences and to the learned president of the Astronomical Society of France, who have made it the subject of important investigations. As for me, I repeat, Terrestrial life is in danger, and I see not one only, but 2, 3, and 4 mortal perils confronting it. Escape will be a miracle, and for centuries no one has believed in miracles." This speech, uttered with a tone of conviction, in a clear, calm, and solemn voice, again plunged the entire audience into a state of mind from which the preceding address had happily released them. The certainty of the approaching disaster was painted upon every face. Some had become yellow, almost green; others suddenly became scarlet, and seemed on the verge of apoplexy. Some few among the audience appeared to have retained their self-possession, though skepticism or a philosophic effort to make the best of it. A vast murmur filled the room. Every one whispered his opinions to his neighbor, opinions generally more optimistic than sincere, for no one likes to appear afraid. The president of the Astronomical Society of France rose in his turn and advanced toward the tribune. Instantly every murmur was hushed. Below we give the main points of the speech, including the opening remarks and the peroration. Ladies and gentlemen, after the statements which we have just heard, no doubt can remain in any mind as to the certainty of the collision of the comet with the earth, and the dangers attending this event. We must therefore expect on Saturday— "On Friday," interrupted a voice from the desk of the Institute. "On Saturday, I repeat," continued the orator, without noticing the interruption, "an extraordinary event, one absolutely unique in the history of the world. I say Saturday, although the papers announce that the collision will take place on Friday, because it cannot occur before July 14th. I passed the entire night with my learned colleague in comparing the observations received, and we discovered an error in their transmission." This statement produced a sensation of relief among the audience. It was like a slender ray of light in the middle of a somber night. A single day of respite is of enormous importance to one condemned to death. Already chimerical projects formed in every mind. The catastrophe was put off. It was a kind of reprieve. It was not remembered that this diversion was of a purely cosmographic nature, relating to the date and not to the fact of the collision. But the least things play an important role in public opinion, so it was not to be on Friday. "Here," he said, going to the blackboard, "are the elements as finally computed from all the observations." The speaker traced upon the blackboard the following figures: Perihelion passage, August 11th, at 0 hour 42 minutes 44 seconds. Longitude of perihelion 52 degrees 43 minutes 25 seconds. Perihelion distance 0.7607. Inclination 103 degrees 18 minutes 33 seconds. Longitude of ascending node 112 degrees 54 minutes 40 seconds. The comet, he resumed, will cross the ecliptic in the direction of the descending node 28 minutes 23 seconds after midnight of July 14th, just as the earth reaches the point of crossing. The attraction of the earth will advance the moment of contact by only 30 seconds. The event doubtless will be altogether exceptional, but I do not believe either that it will be of so tragical a nature as has been depicted, or that it can really bring about blood poison or universal asphyxia. It will rather present the appearance of a brilliant display of celestial fireworks, for the arrival in the atmosphere of these solid and gaseous bodies cannot occur without the conversion into heat of the mechanical motion thus destroyed. A magnificent illumination of the sky will doubtless be the first phenomena. The heat evolved must necessarily be very great. Every shooting star, however small, entering the upper limits of our atmosphere with a cometary velocity, immediately becomes so hot that it takes fire and is consumed. You know, gentlemen, that the earth's atmosphere extends far into space about our planet, not without limit, as certain hypotheses declare, since the earth turns on its axis and moves about the sun. The mathematical limit is that height at which the centrifugal force engendered by the diurnal rotary motion becomes equal to the weight. This height is 6.64 times the equatorial radius of the earth, the latter being 6,378,310 meters. The maximum height of the atmosphere, therefore, is 35,973 kilometers. I do not here wish to enter into a mathematical discussion, but the audience before me is too well informed not to know the mechanical equivalent of heat. Every body whose motion is arrested produces a quantity of heat expressed in caloric units by mv squared divided by 8,338, in which m is the mass of the body in kilograms and v its velocity in meters per second. For example, a body weighing 8,338 kilograms, moving with a velocity of 1 meter per second, would produce, if suddenly stopped, exactly 1 heat unit. That is to say, the quantity of heat necessary to raise 1 kilogram of water 1 degree in temperature. If the velocity of the body be 500 meters per second, it would produce 250,000 times as much heat, or enough to raise a quantity of water of equal mass from 0 degrees to 30 degrees. If the velocity were 5,000 meters per second, the heat developed would be 5,000,000 times as great. Now, you know, gentlemen, that the velocity with which a comet may reach the earth is 72,000 meters per second. At this figure, the temperature becomes 5 milliards of degrees. This, indeed, is the maximum, and I should add a number altogether inconceivable. But, gentlemen, let us take the minimum, if it be your pleasure, and let us admit that the impact is not direct, but more or less oblique, and that the mean velocity is not greater than 30,000 meters per second. Every kilogram of a bolide would develop, in this case, 107,946 heat units before its velocity would be destroyed by the resistance of the air. In other words, it would generate sufficient heat to raise the temperature of 1,079 kilograms of water from 0 degrees to 100 degrees, that is, from the freezing to the boiling point. A uranolite weighing 2,000 kilograms would thus, before reaching the earth, develop enough heat to raise the temperature of a column of air whose cross-section is 30 square meters and whose height is equal to that of our atmosphere, 3,000 degrees, or to raise from 0 to 30 degrees a column whose cross-section is 3,000 square meters. These calculations, for the introduction of which I crave your pardon, are necessary to show that the immediate consequences of the collision will be the production of an enormous quantity of heat, and therefore a considerable rise in the temperature of the air. Now, this is exactly what takes place on a small scale in the case of a single meteorite, which becomes melted and covered superficially by a thin layer of vitrified matter resembling varnish. But its fall is so rapid that there is not sufficient time for it to become heated to the center. If broken, its interior is found to be absolutely cold. It is the surrounding air which has been heated. One of the most curious results of the analysis which I have just had the honor to lay before you is that the solid masses which it is believed have been seen by the telescope in the nucleus of the comet will meet with such resistance in traversing our atmosphere that, except in rare instances, they will not reach the earth entire, but in small fragments. There will be a compression of the air in front of the bolide, a vacuum behind it, a superficial heating and incandescence of the moving body, a roar produced by the air rushing into the vacuum, the roll of thunder, explosions, the fall of denser metallic particles, and the evaporation of the remainder. A bolide of sulfur, of phosphorus, of tin, or of zinc would be consumed and dissipated long before reaching the lower strata of our atmosphere. As for the shooting stars, if, as seems probable, there is a veritable cloud of them, they will only produce the effect of a vast inverted display of fireworks. If, therefore, there is any reason for alarm, it is not, in my opinion, because we are to apprehend the penetration of the gaseous mass of carbonic oxide into our atmosphere, but a rise in temperature which cannot fail to result from the transformation of mechanical motion into heat. If this be so, safety may be perhaps attained by taking refuge on the side of the globe opposed to that which is to experience the direct shock of the comet, for the air is a very bad conductor of heat. The permanent secretary of the Academy rose in his turn, a worthy successor to the Fontenelles and Aragos of the past. He was not only a man of profound knowledge, but also an elegant writer and a persuasive orator, rising sometimes even to the highest flights of eloquence. To the theory we have just heard, he said, I have nothing to add. I can only apply it to the case of some comet already known. Let us suppose, for example, that a comet of the dimensions of that of 1811 should collide squarely with the earth in its path about the sun. The terrestrial ball would penetrate the nebula of the comet without experiencing any very sensible resistance. Admitting that this resistance is very slight, and that the density of the comet's nucleus may be neglected, the passage of the earth through the head of a comet of 1,800,000 kilometers in diameter would require at least 25,000 seconds, that is 417 minutes, or 6 hours 57 minutes, in round numbers, 7 hours, the velocity being 120 times greater than that of a cannon ball, and the earth continuing to rotate upon its axis. The collision would commence about 6 o'clock in the morning. Such a plunge into the cometary ocean, however rarefied it might be, could not take place without producing, as a first and immediate consequence, by reason of the thermodynamic principles which have already been called to your attention, a rise in temperature such that probably our entire atmosphere would take fire. It seems to me that in this particular case the danger would be very serious, but it would be a fine spectacle for the inhabitants of Mars, and a finer one still for those of Venus. Yes, that would indeed be a magnificent spectacle, analogous to those we have ourselves seen in the heavens, but far more splendid to our near neighbors. The oxygen of the air would prove insufficient to maintain the combustion. But there is another gas which physicists do not often think of, for the simple reason that they have never found it in their analysis: hydrogen. What has become of all the hydrogen freed from the soil these millions of years which have elapsed since prehistoric times? The density of this gas being 1/16 that of the air, it must have ascended, forming a highly rarefied hydrogen envelope above our atmosphere. In virtue of the law of diffusion of gases, a large part of this hydrogen would become mixed with the atmosphere, but the upper air layers must contain a considerable portion of it. There, doubtless, at an elevation of more than 100 kilometers, the shooting stars take fire, and the aurora borealis is lighted. Notice here that the oxygen of the air would furnish the carbon of the comet ample material during collision to feed the celestial fire. Thus the destruction of the world will result from the combustion of the atmosphere. For about 7 hours, probably a little longer, as the resistance to the comet cannot be neglected, there will be a continuous transformation of motion into a heat. The hydrogen and oxygen, combining with the carbon of the comet, will take fire. The temperature of the air will be raised several hundred degrees. Woods, gardens, plants, forests, habitations, edifices, cities, villages, will all be rapidly consumed. The sea, the lakes, and the rivers will begin to boil. Men and animals enveloped in the hot breath of the comet will die asphyxiated before they are burned, their gasping lungs inhaling only flame. Every corpse will be almost immediately carbonized, reduced to ashes, and in this vast celestial furnace Only the heart-rending voice of the trumpet of the indestructible angel of the apocalypse will be heard, proclaiming from the sky, like a funeral knell, the antique death song, Solvet Soculum in favilla. This is what may happen if a comet like that of 1811 collides with the earth." At these words the Cardinal Archbishop rose from his seat and begged to be heard. The astronomer, perceiving him, bowed with a courtly grace, and seemed to await the reply of his eminence. "I do not desire," said the latter, "to interrupt the honorable speaker, but if science announces that the drama of the end of the world is to be ushered in by the destruction of the heavens by fire, I cannot refrain from saying that this has always been the universal belief of the Church. The heavens, says St. Peter, shall pass away with a great noise, and the elements shall meet with fervent heat. The earth also, and the works that are therein, shall be burned up. St. Paul affirms also its renovation by fire, and we repeat daily at Mass his words, Eum qui venturus et judicar vivus et mortos et seculum per iguim. Science, replied the astronomer, has more than once been in accord with the prophecies of our ancestors. Fire will first devour that portion of the globe struck by the huge mass of the comet, consuming it before the inhabitants of the other hemisphere realize the extent of the catastrophe. But the air is a bad conductor of heat, and the latter will not be immediately propagated to the opposite hemisphere. If our latitude were to receive the first shock of the comet, reaching us, we will suppose, in summer, the Tropic of Cancer, Morocco, Algeria, Tunis, Greece, and Egypt would be found in the front of the celestial onset, while Australia, New Caledonia, and Oceania would be the most favored. But the rush of air into this European furnace would be such that a storm more violent than the most frightful hurricane, and more formidable even than the air current which moves continuously on the equator of Jupiter with a velocity of 400,000 kilometers per hour, would rage from the Antipodes towards Europe, destroying everything in its path. The earth, turning upon its axis, would bring successively into the line of collision the regions lying to the west of the meridian first blasted. An hour after Austria and Germany, it would be the turn of France, then of the Atlantic Ocean, then of North America, which would enter somewhat obliquely the dangerous area about 5 or 6 hours after France, that is, towards the end of the collision. Notwithstanding the unheard of velocities of the comet and the earth, the pressure cannot be enormous in view of the extremely rarefied state of the matter traversed by the earth. But this matter, containing so much carbon, is combustible, and at perihelion these bodies are not infrequently seen to shine by their own as well as by reflected light. They become incandescent. What then must be the result of a collision with the earth? The combustion of meteorites and bolides, the superficial fusion of the uranolites which reach the earth's surface on fire, all lead us to believe that the moment of greatest heat will be that of contact, which evidently will not prevent the massive elements forming the nucleus of the comet from crushing the localities where they fall, and perhaps even breaking up an entire continent. The terrestrial globe, being thus entirely surrounded by the cometary mass for nearly 7 hours, and revolving in this incandescent gas, the air rushing violently toward the center of the disturbance, the sea boiling and filling the atmosphere with new vapors, hot showers falling from the sky cataracts, the storm raging everywhere with electric deflagrations and lightnings, the rollings of thunder heard above the scream of the tempest, the blessed light of former days having been succeeded by the mournful and sickly gleamings of the glowing atmosphere, the whole earth will speedily resound with the funeral knell of universal doom, although the fate of the dwellers in the Antipodes will probably differ from those of the rest of mankind. Instead of being immediately consumed, they will be stifled by the vapors, by the excess of nitrogen, the oxygen having been rapidly abstracted, or poisoned by carbonic oxide. The fire will afterward reduce their corpses to ashes, while the inhabitants of Europe and Africa will have been burned alive. The well-known tendency of carbonic oxide to absorb oxygen will doubtless prove a sentence of instant death for those farthest from the initial point of the catastrophe. I have taken as an example the comet of 1811, but I hasten to add that the present one appears to be far less dense. "Is it absolutely sure?" cried a well-known voice, that of an illustrious member of the Chemical Society, from one of the boxes. "Is it absolutely sure the comet is composed chiefly of carbonic oxide? Have not the nitrogen lines also been detected in its spectrum? If it should prove to be protoxide of nitrogen, the consequence of its mixture with our atmosphere might be anesthesia. Every one would be put to sleep, perhaps forever. If the suspension of the vital functions were to last but a little longer than is the case in our surgical operations, it would be the same if the comet was composed of chloroform or ether. That would be an end calm indeed. It would be less so if the comet should absorb the nitrogen instead of the oxygen, for this partial or total absorption of nitrogen would bring about in a few hours, for all the inhabitants of the earth, for men and women, for the young and the aged, a change of temperament, involving at first nothing disagreeable, a charming sobriety, then gaiety, followed by a universal joy, a feverish exultation, finally delirium and madness, terminating in all probability by the sudden death of every human being in the apotheosis of a wild saturnalia, an unheard of frenzy of the senses. Would that death be a sad one? "The discussion remains open," replied the Secretary. "What I have said of the possible consequences of a collision applies in the direct impact of a comet like that of 1811. The one that threatens us is less colossal, and its impact will not be direct, but oblique. In common with the astronomers who have preceded me on this floor, I am inclined to believe in this instance in a mighty display of fireworks." While the orator was still speaking, a young girl belonging to the Central Bureau of Telephones entered by a small door, conducted by a domesticated monkey, and darting like a flash to the seat occupied by the president, put into his hands a large, square, international envelope. It was immediately opened, and proved to be a dispatch from the observatory of Gaurisankar. It contained only the following words: "The inhabitants of Mars are sending a photophonic message. Will be deciphered in a few hours." "Gentlemen," said the president, "I see several in the audience consulting their watches, and I agree with them in thinking that it will be physically impossible for us to finish in a single session this important discussion, in which eminent representatives of geology, natural history, and geonomy are yet to take part. Moreover, the dispatch just read will doubtless introduce new problems. It is nearly 6 o'clock. I propose that we adjourn to 9 o'clock this evening, and it is probable that we shall have received by that time from Asia the translation of the message from Mars. I will also beg the director of the observatory to maintain constant communication by telephone with Gaurisankar. In case the message is not deciphered by 9 o'clock, the president of the Geological Society of France will open the meeting with a statement of the investigations which he has just finished on the natural end of the world. Everybody at this moment is absorbingly interested in whatever relates to the question of the end of our world, whether this is dependent upon the mysterious portent now suspended above us, or upon other causes of whatever nature subject to investigation. End of chapter 3. Four of Omega, the Last Days of the World. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Omega, The Last Days of the World, by Camille Flammarion, Part 1, Chapter 4. Part 1. The multitude stationed without the doors of the Institute had made way for those coming out, every one being eager to learn the particulars of the session. Already the general result had in some way become known, for immediately after the speech of the director of the Paris Observatory, the rumor got abroad that the collision with the comet would not entail consequences so serious as had been anticipated. Indeed, large posters had just been placarded throughout Paris announcing the reopening of the Chicago Stock Exchange. This was an encouraging and unlooked-for indication of the resumption of business and the revival of hope. This is what had taken place. The financial magnate, whose abrupt exit will be remembered by the reader of these pages, after rolling like a ball from the top to the bottom row of the hemicycle, had rushed in an aerocab to his office on the Boulevard St. Cloud, where he had telegraphed to his partner in Chicago that new computations had just been given out by the Institute of France, that the gravity of the situation had been exaggerated, and that the resumption of business was imminent. He urged, therefore, the opening of the Central American Exchange at any cost, and the purchase of every security offered, whatever its nature. When it is 5 o'clock at Paris, it is 11 in the morning at Chicago. The financier received the dispatch from his cousin while at breakfast. He found no difficulty in arranging for the reopening of the exchange, and invested several millions in securities. The news of the resumption of business in Chicago had been at once made public, and although it was too late to repeat the same game in Paris, it was possible to prepare new plans for the morrow. The public had innocently believed in a spontaneous and genuine revival of business in America, and this fact, together with the satisfactory impression made by the session of the Institute, was sufficient to rekindle the fires of hope. No less interest, however, was manifested in the evening session than in that of the afternoon, and but for the exertions of an extra detachment of the French Guard, it would have been impossible for those enjoying special privileges to gain admission. Night had come, and with it the flaming comet, larger, more brilliant, and more threatening than ever. And if perhaps one half the assembled multitude appeared somewhat tranquilized, the remaining half was still anxious and fearful. The audience was substantially the same, everyone being eager to know at first hand the issue of this general public discussion of the fate of the planet, conducted by accredited and eminent scientists. Whether its destruction was to be the result of an extraordinary accident, such as now threatened it, or of the natural process of decay. But it was noticed that the Cardinal Archbishop of Paris was absent, for he had been summoned suddenly to Rome by the Pope to attend an ecumenical council, and had left that very evening by the Paris-Rome-Palermo-Tunis tube. "Gentlemen," said the president, "the translation of the dispatch received at the observatory of Gore and Sanker from Mars has not arrived yet, but we shall open the session at once, in order to hear the important communications previously announced, which the president of the Geological Society and the permanent secretary of the Academy of Meteorology have to make to us." The former of these gentlemen was already at the desk. His remarks, stenographically reproduced by a young geologist of the new school, were as follows: "The immense crowd gathered within these walls, the emotion I see depicted upon every face, the impatience with which you await the discussions yet to take place, all, gentlemen, would lead me to refrain from laying before you the opinion which I have formed from my own study of the problem which now excites the interest of the entire world, and to yield the platform to those gifted with an imagination or an audacity greater than mine. For in my judgment the end of the world is not at hand, and humanity will have to wait for it several million years. Yes, gentlemen, I said millions, not thousands. You see that I am at this moment perfectly calm, and that, too, without laying any claim to the sang-froid of Archimedes, who was slain by a Roman soldier at the siege of Syracuse, while calmly tracing geometric figures upon the sand. Archimedes knew the danger and forgot it. I do not believe in any danger whatever. You will not then be surprised if I quietly submit to you the theory of a natural end of the world, by the gradual leveling of the continents and their slow submergence beneath the invading waters. But I shall perhaps do better to postpone for a week this explanation, as I do not for an instant doubt that we may all, or nearly all, reassemble here to confer together upon the great epochs of the natural history of the world. The orator paused for a moment. The president had risen. "My dear and honorable colleague," he said, "we are all here to listen to you. Happily, the panic of the last few days is partially allayed, and it is to be hoped that the night of July 13th to the 14th will pass like its predecessors. Nevertheless, we are more than ever interested in all which has any bearing upon this great problem, and we shall listen to no one with greater pleasure than to the illustrious author of the classic treatise on geology." "In that case, gentlemen," resumed the president of the Geological Society of France, "I shall explain to you what, in my judgment, will be the natural end of the world, if, as it is probable, nothing disturbs the present course of events. For accidents are rare in the cosmical order. Nature does not proceed by sudden leaps, and geologists do not believe in such revolutions or cataclysms, for they have learned that in the natural world everything is subject to a slow process of evolution. The geological agents now at work are permanent ones. The destruction of the globe by some great catastrophe is a dramatic conception, far more so certainly than that of the action of the forces now in operation, though they threaten our planet with a destruction equally certain. Does not the stability of our continent seem permanent? Except through the intervention of some new agency, how is it possible to doubt the durability of this earth, which has supported so many generations before our own, and whose monuments of the greatest antiquity prove that if they have come down to us in a state of ruin, it is not because the soil has refused to support them, but because they have suffered from the ravages of time, and especially from the hand of man? The oldest historical traditions show us rivers flowing in the same beds as today, mountains rising to the same height, and as for the few river mouths which have become obstructed, the few landslides which have occurred here and there, their importance is so slight relatively to the enormous extent of the continents that it seems gratuitous indeed to seek here the omens of a final catastrophe. Such might be the reasoning of one who casts a superficial and indifferent glance upon the external world, but the conclusions of one accustomed to scrutinize closely the apparently insignificant changes taking place about him would be quite different. At every step, however little skilled in observation, he will discover the traces of a perpetual conflict between the external powers of nature and all which rises above the inflexible level of the ocean, in whose depths reign silence and repose. Here the sea beats furiously against the shore, which recedes slowly from century to century. Elsewhere mountain masses have fallen, engulfing in a few moments entire villages and desolating smiling valleys. Or the tropical rains, assailing the volcanic cones, have furrowed them with deep ravines and undermined their walls, so that at last nothing but ruins of these giants remain. More silent, but not less efficacious, has been the action of the great rivers, as the Ganges and the Mississippi, whose waters are so heavily laden with solid particles in suspension. Each of these small particles which trouble the limpidity of their liquid carrier is a fragment torn from the shores washed by these rivers. Slowly but surely their currents bear to the great reservoir of the sea every atom lost to the soil, and the bars which form their deltas are as nothing compared with what the sea receives and hides away in its abysses. How can any reflecting person, observing this action, and knowing that it has been going on for many centuries, escape the conclusion that the rivers, like the ocean, are indeed preparing the final ruin of the habitable world. Geology confirms this conclusion in every particular. It shows us that the surfaces of the soil is being constantly altered over entire continents by variations of temperature, by alterations of drought and humidity, of freezing and thawing, as also by the incessant action of worms and of plants. Hence a continuous process of dissolution, leading even to the disintegration of the most compact rocks, reducing them to fragments small enough to yield at last to the attraction of gravity, especially when this is aided by running water. And thus they travel, first down the slopes and along the torrent beds, where their angles are worn away, and they become little by little transformed into gravel, sand, and ooze. Then in the rivers, which are still able, especially at flood time, to carry away this broken up material and to bear it nearer and nearer to their outlets. It is easy to predict what must necessarily be the final result of this action. Gravity, always acting, will not be satisfied until every particle, subject to its law, has attained the most stable position conceivable. Now, such will be the case only when matter is in the lowest possible position. Every surface must therefore disappear, except the surface of the ocean, which is the goal of every agency of motion, and the material borne away from the crumbling continents must in the end be spread over the bottom of the sea. In brief, the final outcome will be the complete leveling of the land, or more exactly, the disappearance of every prominence from the surface of the earth. In the first place, we readily see that near the river mouths the final form of the dry land will be that of nearly horizontal plains. The effect of the erosion produced by running water will be the formation on the watersheds of a series of sharp ridges, succeeded by almost absolutely horizontal plains, between which no final difference in height greater than 50 meters can exist. But in no case can these sharp ridges, which on this hypothesis will separate the basins, continue long, for gravity and the action of the wind, filtration, and change of temperature will soon obliterate them. It is thus legitimate to conclude that the end of this erosion of the continents will be their reduction to an absolute level, a level differing but little from that at the river outlets. The coadjutor of the Archbishop of Paris, who occupied a seat in the tribune reserved for distinguished functions, arose, and as the orator stopped speaking, added, "Thus will be fulfilled to the letter the words of Holy Writ, for the mountains shall depart and the hills be removed." If then, resumed the geologist, nothing occurs to modify the reciprocal action of land and water, we cannot escape the conclusion that every continental elevation is inevitably destined to disappear. How much time will this require? The dry land, if spread out in a layer of uniform thickness, would constitute a plateau of about 700 meters altitude above sea level. Admitting that its total area is 145 million square kilometers, it follows that its volume is about 101,500,000, or in round numbers 100 million cubic kilometers. Such is the large yet definite mass with which the external agencies of destruction must contend. Taken together, the rivers of the world may be considered as emptying every year into the sea 23,000 cubic kilometers of water, in other words, 23,000 milliards of cubic meters. This would give a volume of solid matter carried yearly to the sea equal to 10.43 cubic kilometers, if we accept the established ratio of 38 parts of suspended material in 100,000 parts of water. The ratio of this amount to the total volume of the dry land is 1 to 9,730,000. If the dry land were a level plateau of 700 meters altitude, it would lose by fluid erosion alone a slice of about 7/100ths of a millimeter in thickness yearly, or 1 millimeter every 14 years, say 7 millimeters per century. Here we have a definite figure expressing the actual yearly continental erosion, showing that if only this erosion were to operate, the entire mass of unsubmerged land would disappear in less than 10 million years. But rain and rivers are not the only agencies. There are other factors which contribute to the gradual destruction of the dry land. First, there is the erosion of the sea. It is impossible to select a better example of this than the Britannic Isles, for they are exposed by their situation to the onslaught of the Atlantic, whose billows, driven by the prevailing southwest wind, meet with no obstacle to their progress. Now, the average recession of the English coast is certainly less than 3 meters per century. Let us apply this rate to the sea coasts of the world and see what will happen. We may proceed in 2 ways. First, we may estimate the loss in volume for the entire coastline of the world on the basis of 3 centimeters per year. To do this, we should have to know the length of the shoreline and the mean height of the coast. The former is about 200,000 kilometers. As to the present average height of the coasts above the sea, 100 meters would certainly be a liberal estimate. Hence, a recession of 3 centimeters corresponds to an annual loss of 3 cubic meters per running meter, or for the 200,000 kilometers of coastline, 600 million cubic meters, which is only 6/10 of a cubic kilometer. In other words, the erosion due to the sea would only amount to 1/17 that of the rivers. It may perhaps be objected that as the altitude actually increases from the coastline toward the interior, the same rate of recession would in time involve a greater loss in volume. Is this objection well founded? No, for the tendency of the rain and water courses being, as we have said, to lower the surface level, this action would keep pace with that of the sea. Again, the area of the dry land being 145 million square kilometers, a circle of equal area would have a radius of 6,800 kilometers, but the circumference of this circle would be only 40,000 kilometers. And that is to say, the sea could exercise upon the circle but 1/5 the erosive action which it actually does upon the indented outline of our shores. We may therefore admit that the erosive action of the sea upon the dry land is 5 times greater than it would be upon an equivalent circular area. Certainly this estimate is the maximum, for it is logical to suppose that when the narrow peninsulas have been eaten away by the sea, the ratio of the perimeter to the surface will decrease more and more, that is, the action of the sea will be less effective. In any event, since at the rate of 3 centimeters per year, a radius of 6,800 kilometers would disappear in 226,600,000 years. 1/5 of this interval, or about 45 million years, would represent the minimum time necessary for the destruction of the land by the sea. This would correspond to an intensity of action scarcely more than 1/5 that of the rivers and rain. Taken together, these mechanical causes would therefore involve every year a loss in volume of 12 cubic kilometers, which for a total of 100 million would bring about the complete submergence of the dry land in a little more than 8 million years. But we are far from having exhausted our analysis of the phenomena in question. Water is not only a mechanical agent, it is also a powerful dissolvent, far more powerful than we might suppose, because of the large amount of carbonic acid which it absorbs either from the atmosphere or from the decomposed organic matter of the soil. All subterranean waters become charged with substances which it has thus chemically abstracted from the minerals of the rocks through which it percolates. River water contains per cubic kilometer about 182 tons of matter in solution. The rivers of the world bring yearly to the sea nearly 5 cubic kilometers of such matter. The annual loss to the dry land, therefore, from these various causes is 17 instead of 12 cubic kilometers, so that the total of 100 million would disappear not in 8, but in a little less than 6 million years. And this figure must be still further modified, for we must not forget that the sediment thus brought to the sea and displacing a certain amount of water will cause a rise of the sea level, accelerating by just so much the leveling process due to the wearing away of the continents. It is easy to estimate the effect of this new factor. Indeed, for a given thickness lost by the plateau heretofore assumed, the sea level must rise by an amount corresponding to the volume of the submarine deposit, which must exactly equal that of the sediment brought down. Calculation shows that in round numbers the loss in volume will be 24 cubic kilometers. Having accounted for an annual loss of 24 cubic kilometers, are we now in a position to conclude what time will be necessary for the complete disappearance of the dry land, always supposing the indefinite continuance of present conditions? Certainly, gentlemen, for after examining the objection which might be made apropos of volcanic eruptions, we find that the latter aid rather than retard the disintegrating process. We believe, therefore, that we may fearlessly accept this above estimate of 24 cubic kilometers as a basis of calculation, and as this figure is contained 4,166,666 times in 100 million, which represents the volume of the continents, we are authorized to infer that under the sole action of forces now in operation, provided no other movements of the soil occur, the dry land will totally disappear within a period of about 4 million years. But this disappearance, while interesting to a geologist or a thinker, is not an event which need cause the present generation any anxiety. Neither our children nor our grandchildren will be in a position to detect in any sensible degree its progress. If I may be permitted, therefore, to close these remarks with a somewhat fanciful suggestion, I will add that it would be assuredly the acme of foresight to build today a new ark in which to escape the consequences of this coming universal deluge. Such was the learnedly developed thesis of the president of the Geological Society of France. His calm and moderate statement of the secular action of natural forces opening up a future of 4 million years of life had allayed the apprehension excited by the comet. The audience had become wonderfully tranquilized. No sooner had the orator left the platform and received the congratulations of his colleagues than an animated conversation began on every side. A sort of peace took possession of every mind. People talked of the end of the world as they would of the fall of a ministry or the coming of the swallows, dispassionately and disinterestedly. A fatality put off 40,000 centuries does not really affect us at all. But the permanent secretary of the Academy of Meteorology had just ascended the tribune, and everyone gave him at once the strictest attention. Ladies and gentlemen, I am about to lay before you a theory diametrically opposed to that of my eminent colleague of the Institute, yet based upon facts no less definite and a process of reasoning no less rigorous. Yes, gentlemen, diametrically opposed. The orator, gifted with an excellent voice, had perceived the disappointment settling upon every face. "Oh," he said, "opposed, not as regards the time which nature allots to the existence of humanity, but as to the manner in which the world will come to an end. For I also believe in a future of several million years. Only, instead of seeing the subsidence and complete submergence of the land beneath the invading waters, I foresee, on the contrary, death by drought, and the gradual diminution of the present water supply of the earth. Some day there will be no more ocean, no more clouds, no more rain, no more springs, no more moisture, and vegetable as well as animal life will perish, not by drowning, but through lack of water. On the earth's surface, indeed, the water of the sea, of the rivers, of the clouds, and of the springs is decreasing. Without going far in search of examples, I would remind you, gentlemen, that in former times, at the beginning of the Quaternary period, the site now occupied by Paris, with its 9 million of inhabitants, from Mount Saint Germain to Villeneuve Saint George, was almost entirely occupied by water, Only the hill of Passy, of Montmartre and Père Lachaise, and the plateau of Montrouge at the Pantheon and Villejuif emerged above this immense liquid sheet. The altitudes of these plateaus have not increased. There have been no upheavals. It is the water which has diminished in volume. It is so in every country of the world, and the cause is easy to assign. A certain quantity of water, very small it is true in proportion to the whole, but not negligible, percolates through the soil, either below the sea bottoms by crevices, fissures, and openings due to submarine eruptions, or on the dry land, but not all the rain water falls upon impermeable soil. In general, that which is not evaporated returns to the sea by springs, rivulets, streams, and rivers, but for this there must be a bed of clay over which it may follow the slopes. Wherever this impermeable soil is lacking, it continues its descent by infiltration and saturates the rocks below. This is the water encountered in quarries. This water is lost to general circulation. It enters into chemical combination and constitutes the hydrates. If it penetrates far enough, it attains a temperature sufficient for its transformation into steam, and such is generally the origin of volcanoes and earthquakes. But within the soil, as in the open air, a sensible proportion of the water in circulation becomes changed into hydrates, and even into oxides. There is nothing like humidity for the rapid formation of rust. Thus recombined, the elements of water, hydrogen and oxygen, disappear as water. Thermal waters also constitute another interior system of circulation. They are derived from the surface, but they do not return there, nor to the sea. The surface water of the earth, either by entering into new combinations or by penetrating the lower rock strata, is diminishing, and it will diminish more and more as the earth's heat is dissipated. The heat wells which have been dug within 100 years in the neighborhood of the principal cities of the world, and which afford the heat necessary for domestic purposes, will become exhausted as the internal temperature diminishes. The day will come when the earth will be cold to its center, and that day will be coincident with an almost total disappearance of water. For that matter, gentlemen, this is likely to be the fate of several bodies in our solar system. Our neighbor, the moon, whose volume and mass are far inferior to those of the earth, has grown cold more rapidly, and has traversed more quickly the phases of its astral life. Its ancient ocean beds, on which we today recognize the indubitable traces of water action, are entirely dry. There is no evidence of any kind of evaporation. No cloud has been discovered, and the spectroscope reveals no indication of the presence of the vapor of water. On the other hand, the planet Mars, also smaller than the earth, has beyond a doubt reached a more advanced phase of development, and is known not to possess a single body of water worthy of the name of ocean, but only inland seas of medium extent and slight depth, united with each other by canals. That there is less water on Mars than on earth is a fact proved by observation. Clouds are far less numerous. The atmosphere is much drier. Evaporation and condensation takes place with greater rapidity, and the polar snows show variations depending upon the season much more extensive than those which take place upon the earth. Again, the planet Venus, younger than the earth, is surrounded by an immense atmosphere, constantly filled with clouds. As for the large planet Jupiter, we can only make out, as it were, an immense accumulation of vapors. Thus, the four worlds of which we know the most confirm, each in its own way, the theory of a secular decrease in the amount of the earth's water. I am very happy to say in this connection that the theory of a general leveling process maintained by my learned colleague is confirmed by the present condition of the planet Mars. That eminent geologist told us a few moments ago that owing to the continuous action of rivers, plains almost horizontal would constitute the final form of the earth's surface. That is what has already happened in the case of Mars. The beaches near the sea are so flat that they are easily and frequently inundated, as everyone knows. From season to season, hundreds of thousands of square kilometers are alternately exposed or covered by a thin layer of water. This is notably the case on the western shores of the Kaiser Sea. On the moon this leveling process has not taken place. There was not time enough for it. Before its consummation the air, the wind, and the water had vanished. It is then certain that while the earth is destined to undergo a process of leveling, as my eminent colleague has so clearly explained, it will at the same time gradually lose the water which it now possesses. To all appearances the latter process is now going on more rapidly than the former. As the earth loses its internal heat and becomes cold, crevices will undoubtedly form, as in the case of the moon. The complete extinction of terrestrial heat will result in contractions, in the formation of hollow spaces below the surface, and the contents of the ocean will flow into these hollows without being changed into vapor, and will be either absorbed or combined with the metallic rocks in the form of ferric hydrates. The amount of water will thus go on diminishing indefinitely, and finally totally disappear. Plants deprived of their essential constituent will become transformed, but must at last perish. The animal species will also become modified, but they will always be herbivora and carnivora, and the extinction of the former will involve inevitably that of the latter. And at last the human race itself, notwithstanding its power of adaptation, will die of hunger and of thirst on the bosom of a dried up world. I conclude, therefore, gentlemen, that the end of the world will not be brought about by a new deluge, but by the loss of its water. Without water, terrestrial life is impossible. Water constitutes the chief constituent of every living thing. It is present in the human body in the enormous proportion of 70%. Without it, neither plants nor animals can exist, either as a liquid or in a state of vapor. It is the condition of life. Its suppression would be the death warrant of humanity, and this death warrant nature will serve upon us a dozen million years hence. I will add that this will take place before the completion of the erosion explained by the president of the Geological Society of France, for he himself was careful to note that the period of 4 million years was dependent upon the hypothesis that the causes now in operation continue to act as they do today. And furthermore, he himself admits that the manifestations of internal energy cannot immediately cease. Upheavals at various points will occur for a long period, and the growth of the land area from such causes as the formation of deltas and the volcanic and coral islands will still go on for some time. The period which he indicated, therefore, represents only the minimum. Such was the address of the permanent secretary of the Academy of Meteorology. The audience had listened with the deepest attention to both speakers, and it was evident from its bearing that it was fully reassured concerning the fate of the world. It seemed even to have altogether forgotten the existence of the comet. The president of the Physical Society of France has the floor. At this invitation, a young woman, elegantly dressed in the most perfect taste, ascended the tribune. My two learned colleagues, she began, without further preamble, are both right. For on the one hand, it is impossible to deny that meteorological agents, with the assistance of gravity, are working insensibly to level the world, whose crust is ever thickening and solidifying. And on the other hand, the amount of water on the surface of our planet is decreasing from century to century. These two facts may be considered as scientifically established. But, gentlemen, it does not seem to me that the end of the world will be due to either the submergence of the continents or to an insufficient supply of water for plant and animal life. This new declaration, this announcement of a third hypothesis, produced in the audience an astonishment bordering upon stupor. Nor do I believe, the graceful orator hastened to add, that the final catastrophe can be set down to the comet. For I agree with my two eminent predecessors that worlds do not die by accident, but of old age. Yes, doubtless, gentlemen, she continued, the water will grow less, and perhaps in the end totally disappear. Yet it is not this lack of water which in itself will bring about the end of things, but its climatic consequences. The decrease in the amount of aqueous vapor in the atmosphere will lead to a general lowering of the temperature, and humanity will perish with cold. End of chapter 4, Part 1